Okay, so let's do a shaft drawing, shaft in SolidWorks. Here is the layout that we have right here. We might want to like capture that, write that down, sketch it. We made all those decisions. The widths we decided were 40 for the gears, and the let's see, the bearings. Sorry, I went backwards here. The bearings are 23 millimeters, right? So we want to write that down. 23 millimeters, 40 millimeters wide. Those are the widths. These lengths, 400, 350, and 300 are very important. So that's how we're going to start. We will create a new part. We will get rid of our, I know not everybody has this little pull down for some reason. My God, I hate the smog. Get rid of it. I'm going to pull up my units over here in the bottom right where it says the IPS. Let's stick with millimeters instead of meters. That's fine. Now, here is my philosophy. First off, I'm going to start with the right plane, and that's where the bearing is going to land, the center of the bearing. And we're picking the right plane because X is going to be, we're aligned with the X axis right there. I'm going to make this visible, right, with the little eye, right clicking him and getting the eye. And then I'm going to go to features and go to reference geometry and make a plane. All right, so we have a bunch of different methods to make a plane. I'm going to click on this guy, and the method that comes up is going to be an offset. So looking back over at here, we had 400. So I'm going to make 400 millimeters is going to be my offset. So I can get to the center of the plane. Now I'm going to be doing this thing again and again. So I'm going to click, before I hit the green, I've decided to click on that little thumbnail right there. And that's going to mean that this stays open. There you go. All right. So now that just jumped to this one that has not been established yet. So plane one is now 400 over. We're going to go 350 this time. 350. I just clicked anywhere right there just to get it to go. And now that should be 350 in between there. And then lastly, that should be 300 right here. Let's go 300. And we can unclick that right there before we hit the green. Boom, we're done. So we have 3 planes, and they are the correct distance apart. Now I'm going to draw on these planes. I'm going to draw little hockey pucks for the bearing, for the thing that's sitting on the gear, for the thing sitting on the gear, for the other bearing. And we'll see, and then we're going to join them with these other parts right there. What we're doing here is we're making sure that no matter what, we get the exact right placement of our thing. It does take some thought processes. So I just created a sketch onto that plane, even though they all look like they're on top of each other. And then pick the center point of the thing. And so these should be 65 millimeters. All right. So now I'm going to go to this gear, and that should be 100 millimeters right there. That's that guy right there. So I'll put a sketch on him. I'm on the right plane, right? Yep, that's the plane. I can even draw it over here to the side. I don't have to be in front of it. And 100. Boom. I can get out. I'm going to click on this plane. All right. And this should be 120. 120. Boom. And just double checking. Yeah, that's the one that I was just on. Okay. And then lastly, I want to do this one. And no, I didn't want to hit that. Sorry. Yeah, get that. All right. So here you go. I think actually I could have stayed on that, but that's okay. I clicked on the wrong thing. And then we could, by the way, draw that circle, but we already have a 65 millimeter circle. And we don't always do this, but see, even though I'm in the sketch that's in the plane 3, I can still touch things that are in the other. And I can hit nice convert entities. Boom. That just made that circle the same. What's nice about that is if I go back to here and change that diameter, this one will change too. It only works when it works, but it works. All right, so here we want this one to be 23 millimeters, right? 23 millimeters. So I will go to, I have it pre-selected. I'm going to go to Features, Extrude. And what's nice is we could use the mid plane. So now that whatever we make right here, 23 millimeters, it'll be in the middle of that, right? So we can kind of look to the side. You can see we go both to the left and to the right. Boom. And just to save us a little itty bitty amount of time, we can go to this sketch right here, which is that one right there, and do the same thing. And because it's already loaded up, we didn't have to write in 23 millimeters again. It already knew. So we got those 2 hockey pucks made. Somebody's calling me, and I don't know. I bet it's a politician. It just says New Britain, Connecticut. Who could it be now? Do I have anybody? Do I have anything scheduled for today? No, just office hours. So I'm not disappointing anybody. Very, very persistent. All right, so we're going to go do sketch 2. Now, this should be 40 millimeters, right, for the gears. Because if you went to the very beginning here, the difference was 385 and 425. That was 40. And this is 325 and 285, so that was 40. And, of course, I already admitted I should have recognized that that's not exactly in the center. They don't tell you what it is, so that's why we're stuck here. That's why we're at where we're at, as it were. All right, so 40 into here. Boom. Come on. And then do it one more time. And of course, we've already loaded up with 40, so it should be fine. We don't need to see these planes anymore, so we can hide them all. I hit Shift, select them all. Boom. Got rid of them. Yay. All right, so now we got a choice which one to do first. Let's do the middle one first. We want to make a 150 diameter that goes from the end of this gear to the end of this gear. So let's make it onto there. Let's draw it onto that face. So I'm going to sketch it onto that face. Boom. And of course it pivoted towards us, but we'll be fine. So we're going to go to there and put in 150 and boom. And so we're going to take that sketch and we're going to extrude it, but we're going to change. It's not going to be a mid plane. It's going to be up to surface. Boom. Oh, and by the way, in this little interim thing, we've created multiple bodies. So if you expanded, you could see that that you have 3 separate bodies. Right? They're not merged, but you risk when doing this approach that you didn't realize you should merge these pieces. Like notably, make sure merge result is included there. Otherwise, you'll have multiple bodies. They'll be floating. Just to let you know. But see, that worked out. And now we want to do the same kind of idea for between here and here. So we'll sketch on that face. Could have picked either one, by the way. And we will go, I believe this was 80. Yeah, we went to 80. Okay. And label him 80. We're still in Sketch, buddy. All right. So now we're going to go to features. We could pre-highlight that sketch. I like to do that. It still has up to surface, so that's going to still work for us. Okay, so we go up to that surface. Boom. And while we're here, notice that the transitions from that diameter to that diameter, they look fairly reasonable. Fairly reasonable. All right, so last one right here, and that's going to be 95 millimeters. So we'll make a sketch onto that face, 95 millimeters, little happy trees. Everything. I always feel like I'm kind of a little bit of a channeling Bob Ross when I'm doing these videos, when I'm talking to myself. Of course, he probably had like a cameraman and a sound person, that kind of thing. I'm just here by myself in my office. And we're gonna go up to that surface. Boom. Yay, we have made ourselves a shaft. And let's say that we save as and go to, this is a class, is this class 12? I think it's class 12. I just write for video. Is that enough description? Well, I'm not going to keep it like forever. All right, so I want to look at this thing from this direction in the drawing. So I'm going to put my keyway on this face. First, I kind of need to do the fillets. Let's add the fillets in there. All right, so what do we decide? We're going to use 2.5 for right here. And one of the best parts of doing this is we're answering the question of, does this make sense in terms of the values, right? So there's 10 millimeters. That doesn't make sense. For a gear, it would be tough to get that to go in here. We have established that based on the criteria in the book is using for, just a representative fillet. So we picked like right around 2.5. That looks like it makes kind of sense. It doesn't answer that question. Does that make sense? I think that does. Boom. So we've answered that. Okay, so the other fillets to deal with, we have one that's here we said 10 millimeters. Now this one doesn't make a lot of sense to me, but I went ahead and stuck with it. So, all right, so we're going to put these back in there, even though, boom. Ten seems excessively large to me. Yeah, that looks big. We're going to leave it though. And then lastly, I'm going to put in the, so I don't even think it'll let me do 10 there. Oh, that's huge. That's going to be 1.5, and we'll just go ahead and leave it as the same as what the bearings are, even though we probably actually want to go down to like smaller, like 1. Ooh, what happened here? Oh, I picked face. One edge only. There you go. So there's the 1.5. Lastly, we don't need to do this. We could actually just make this with a note, but I'm going to go ahead and make a make a keyway. And here's how I would do it if I were to do it. I would, first off, I'd make a plane. This would be the front plane because I'm going to show this in the XY plane on my drawing. So it would be nice to be able to have something that I put in there. So I put that plane in there in my features for my reference geometry. I make a plane, and I'm going to make it 1/2 of the, I'm going to, whoop, it's not letting me do it. Did it freeze up? Okay, so we're back. Yeah, I don't know what the hell happened. So I'm going to take a front plane, and hopefully I won't crash it again. And what is 1/2 of the first diameter? Is it 50 millimeters? I'm going to go 50 millimeters. So that's going to land a plane, boom, right there. So it's going to be right there on the edge. If I look from the top of it, it's going to be right there. So I can go ahead and make a sketch on that plane. And I've decided I'm going to use a center line that I could take off of this edge right there. Boom. Right? I'll escape out. So now I've made that. I can make that if I want to. 20 millimeters. So that is exactly 1/2 of the way through. And as we pointed out before, maybe it's not actually, maybe we don't actually want to use 1/2 of the 40 for the center of the gear, but we're pretending it is. So now I have pulled this down for the rectangle. So I'll make a rectangle that starts in the middle. Oh, didn't do it. There you go. Boom. And I didn't do the calculations yet, but here they are for this example, right? I decided to go with a 20 millimeter by 28, all right? So we can go do that example later on, and we could see that's how I picked those. As opposed to picking one from this table right there, which is kind of out of our range, right? We're at 100 millimeters is like 4 inches, and that's larger than we have right here. I do have this excerpt from Machinery's Handbook for this right here, and so in between 95 and 110, they're going 28 by 16, 28 being the width, 16 being the height. 28 seems a little big to me when I went to go do the calculation there. I went 28 in this direction, and then I decided on 20 millimeters. So we're just going to stick with that and use it for both sides. So here's my 28. It looks like it fits, and I calculate it later on. So that's what I decided fits for this here. And because it's 28 wide, I'm going to make it 14 deep in terms of my cut. Right, so you can't quite see that. But, you know, if I made a through one all the way through, it would cut into this shaft. So that's the reason why I decided this we're just going to go in that way downwards. So I'm going to go 14. No, I guess I'm going 10, right? Because it's a square key. I made it 20 wide, so it should be 20 tall, so it should be 10 deep. Yeah, so 10 deep actually makes sense right there. So I think that's fine. And it actually could have gone through here, but it would have messed up this fillet. And I would actually, in reality, probably put small, little, tiny fillets on the bottoms and of the corners of these instead of the hard edge. So I did that one in that plane. I'm going to hide that. I'm going to do the same thing again. By the way, I'm going to hit save because I don't trust this thing crashing anymore. Front, and then another plane. Boom. And now this one should be, what, 60? Yes, that lands just on the edge of that. So I will make a sketch here and do this more quickly because this has become a long video. We want to get to the drawing part of it. This is why this is going to be a long assignment, unfortunately. There are lots of things to do. But we said that was 20. We made this 28. Oh, what happened? Oh, we didn't decide what that was. We got to make that 20 to land this exactly in the right spot. And then take the features and make it the same. Boom. Yeah, it was going down. All right. Great. And let's hide this plane again. Now we can set this thing up for the FEA and so forth, but let's just make the drawing now. So we make a new thing and make a drawing, and we're going to set this up for a B landscape. So this B, I never think this preview looks right, but anyway, that's an 11 by 17 drawing. That's the idea. So this pops up. We will go boom, and I wrote for video here. I'm gonna initially place there after I did that little blue arrow right thing over to the right. I should have pointed that out. That this is wicked too small. We don't need to do this. This drawing, this view is useless right there. Nobody can tell what that is, and we don't need to have that drawing. That view doesn't do it. We only need this one view, and then even these views right here, they're not necessary. I kind of like an isometric view, but we don't really need to see it to understand it. So I would leave it off. I hit escape just now. Now we are not using our space. This is what the sheet, for whatever reason, decided to go 1/8 scale by default. Let's use a custom scale. I clicked on, by the way, I clicked on the outside little guy right there. That's what brings this up. And we're going to try out the different scales. Can we go to one size large? That's actually not too bad. This is a weird scale. Nobody wants to do 2 to 3. So I think 1 to 4 is about the best we're going to do in terms of a sensible one. But by the way, it didn't change it down here. We changed it there, but we could also have changed what the sheet scale was, I think. I don't remember, actually. I haven't done it in a while, but I bet we did. But just let's make sure we fix that to make that accurate. And now we're going to start to do the dimensioning portion of this. I think if something's round, you need to use the center line. So we pick that center line and pick that guy right there. And you only need one because you could stretch him. All right, so we stretch him all the way through. That tells everybody this thing is round, right? It also we're also going to tell us that what else will tell us around is we're going to put a bunch of things that have the diameter with the diameter symbol next to it. All right, now this is not necessarily done all the time, but I prefer when we have something like this to add in some annotation sketches to show the center of things, right? So I'm going to pull down these centers. And this might take longer than necessary, so I'm sorry for that. I'm going to go up to this bearing, and I'm going to click over here onto this. I know that's not the center, but by putting that fillet there, we got rid of the other corner that I would normally attach it to. So I'm attaching it to this line right here. And then I'm going to come in afterwards, touch that end, hold down Control, and hold down that edge. And then I'm going to hit coincident. Now you can see that it's just that makes it coincident to both that edge and to that edge. So that's going to establishing the center of it. So that's the reason why I'm doing it. And I'm using these center lines because they imply that this is not an actual edge on the piece, but in fact something that you're trying to give information about. So I did it again. Here I'm holding down the Control, boom. So I have both the end of it selected and that edge, and I go coincident. Now I have exactly the center of that piece, and I can dimension that. And I want to do that because I want to communicate these very essential dimensions, the overall dimensions, and I think they're important. I'm going to do the same thing here. I'll do it relatively quickly. For the gears. So I'm doing them at corners, I know, and I'll put them at edges right there. right there, and then I'll pick that point and hold down Control. Whoops, stop. I'm picking the wrong thing. There you go. Clicked on that edge, clicked on that point, converge. Oh, coincident. I'm sorry. Pick on that point, pick on that edge. Coinkydink. You're good. Do the same thing again here. I could pick on that edge too, by the way. I mean, I could just put it onto that edge because we're just going to do that in a second. Boom. Boom, boom. I don't know who that is. All right, I'm going to pick that point. Control. Coincident. Is it a coincidence? Control, boom. Coincidence. And the last one. If it wasn't for that fillet. And by the way, back in the day when we were doing everything in AutoCAD, we wouldn't even draw I wouldn't even draw the fillet in there. I'll just label it that it's a fillet. You wouldn't even notice. You don't need to draw a thing. You could just label it and tell somebody that it's a fillet. But now we got to model every single thing and label every single thing and find ways around SolidWorks being very particular about doing things the way it wants to do. All right, so there you go. Whoop, that ain't working. What's wrong with him? How come? Well, I guess he's solved. I'm a little leery. I didn't see it change. It didn't change to black. Anyway, okay. So now I've spent way more time than you wanted to doing these dimensions. I'm going to put on these major dimensions here. Hopefully, it'll let me grab it right by the centers. Right by the center. Oops, I made a mistake. I need to change into overall things. I probably a bunch of other places you could change that, by the way. There you go. And I don't remember off the top of my head the methods of changing the drawing standards, but this is sort of a European. I think this ISO standard is to put the numbers on top of the line as opposed to breaking the line instead. I think that's a US standard, maybe in AISI. I don't know. ASTM. I don't know. So we're going to make this dimension driven, which is to say that it wants to say, oh, it's already made a decision. By the way, looking at my drawing thing, my smart dimensions, you could make baseline dimensions and other types of things. I'm just going to leave it with the default. It's not going to hurt anything. I believe I have to go for my next dimension right from that thing to there. Be nice if they were connected to each other. But anyway, I'm going to make a ref next to all three of these, which is just to say that I want the machinist to know this information. Oh, look, you can see that blue right there. The blue tells me something's wrong. Is that not connected down here? Yeah. Oh, there you go. There you go. He's black now. Okay. I think it would have been fine, but I had a suspicion that perhaps it wasn't completely defined. We would like to define stuff. These little yellow things kind of establishing that these are connected. Sometimes these dimensions will jump around on you, drive you a little nuts. So I put all these on here. They don't need this many decimal places. I guess we could change them. Like I could just go down to here. We had 1 or none. And look, it jumped like that. I can't stand these weird things SolidWorks does like that. I don't know why. he decided that he needs to be down there too, right? So they made a decision where they want to be. I think on here, I'm going to put next to that dim, which is like with the little carrots to make a decision, or set a thing. Get produce this. Like we could overwrite that by canceling out that dim, but I'm just going to hit and add a ref next to each of these, just to say it's my reference. This isn't like the way to necessarily do it, but I think it's helpful. All right, so those are a little too close for my comfort to the thing, because I want some other dimensions in there. My first dimension that I care about the most is this guy right here. And I think I need to go back in and change the number of decimal places globally, but we're going to leave it. We're going to leave it for right now. And then what I'm going to do is I'm going to go left to right of what I think is in things that we need to know. All right, so here's a 23. If I was using US units, and I know that this is 23 millimeters, but in US units, it would have converted into inches. I would have also put a secondary dimension, like a dual dimension down below, which would have given, in this case, there's an inch right there, which would have given the metric one. So I can let people know, because you go like, well, you give it 0.9 whatever inches. You don't necessarily know that, well, it's 23. That it just happens to convert to that. So it's good to give the dual dimension to let them know that that's what you were doing. I'm going to go and give this dimension 2 here to here. And I kind of want to line them up right to there. All right. Now, here's the thing I don't like. I wanted this up higher so I could dimension that to that edge and keep him lined up. I like having them lined up. They look good that way to me. I'm going to go ahead and dimension off this way right here and kind of do the same thing. I mean, there's no, you could have put like TYP next to a dimension if it's the same dimension in multiple places, but there's only 2 places, so it's fine. I think you can tell from that that's the dimensions that you want. And then finally that to, well, I don't feel like I'm grabbing him to that. Yeah. Okay. Got it. These would be a little bit higher up to line it up. Boom, boom. Oh yeah, I wanted that lined up to there. These lined up. I'm not sure this is the right way to do it. I think actually this would be more appropriate. I think people would understand what it is you're describing from what I just did right there. And then the thing I left out right here, I didn't tell them how long this should be. Like because I gave them this full length, and I gave, but the length of this doesn't really matter. It is 310, and that is, maybe you want to put it in there, but I didn't feel it was necessary. Now I've decided that I want to put all my diameters on the bottom. So I'm grabbing both edges right there. Boom. Whoops. I guess I fell out of my smart. And by the way, there's a whole bunch of different ways to dimension. This is what I choose. Is I'm going to come down here and I'm going to go down below. I did the widths. Whoops. I did the widths, or I should say the axial position on the top. I did the diameters below. Is that the exact way to do it? No, not necessarily. It's how I chose to do it. And I'm doing my best not to cross things, but it's hard not to here. Like I can pull this over to there. What I'm going to have a problem when doing that is then when I go to do that fillet radius, this fillet radius right here is not an easy position to not to cross these up. First off, I had to cross that line. I hate doing it. Hate doing it. Come on. No. I hate it when that edge. Give me an edge. There you go. All right. And oh, and by the way, it looks a lot better when you go like, you get these little yellow things to make them the same. Now it's all a little, there's a little bit of, I don't want to say artistry. There's a little bit of flair, decisions that you have to make to be able to communicate what you want. You want to make it nice and clear to everyone involved what it is that you're trying to accomplish. Let's see, I'm going to make that one to there. I think it's right. And then lastly, I still have all the fillets to mention. To do. All right, so this fillet, wicked small, hard to communicate. This one is the really tough one because it's in the frickin' way. Did you have to say frickin'? It's not really a swear. Right in there. You almost want to make these guys kind of parallel to each other, right? It's not necessary. It looked good though. And then I didn't. And then here's the last one. I hope this video isn't too long. I bet it's gonna be too long. See, I kind of like it that angle. So now I'm gonna move this guy over just a little bit. Okay. All right, now last thing to do here on the dimensioning is the keyway. I think personally that you don't want to necessarily dimension it. Personally, I think I want to do it with a note. So I'm putting this note up here. And where do you put the note? I could put the note right in there, and I'm only crossing one line. I could put it over here. I can't really quite get it over there. So I think I want to have it over here, even though I don't like the fact that I am, anyway, I don't like the fact that it's crossing a line right there. But let's see if we can fix it later. 20 mm square by 28 long key. All right, and I'm going to go 2 places. All right, so that saves me a little bit. I think I'm gonna stay with. I gotta hit escape. It's in the frickin' way. It's not in a great place right here, and unfortunately, look how much stuff I have to cross. It's not a good spot. So what you might do is write C note or C note, and then have it numbered or lettered or what have you. There's not a great place. But even the dimensioning of it is not a great place. So I'm going to get rid of that and wrote C note. Boom. Right? Because you can't fit it in there. I mean, whatever. So you don't really want to have any of the numbers laying on top of the actual piece. Everything should be onto the outside of it right here. And we might want to put a note someplace right here. And then I'm going to, key 2 places. And I might go note. And if you had more notes, you'd put them up. And we might want to, we don't have to put that in multiple places. We might want to put like that right down there. Sometimes we put it up in the upper left-hand corner. It could be other places. All right, so we should be saving this at some point. And I'm just going to keep it, I call it for video. And we want to enter the title block, right? So I'm making this full service video all the way through where you can see all the things that we need to do. So we want to go over here in this tree and hit sheet format and edit sheet format. So first off, give it some kind of number. F25 MENG3125 PS7, right? All of those things are true, right? But so we've generated this fake drawing, but we might have a drawing numbering system in your company. Now I'm going to make it small enough to fit into there. I think 16. Nope, got to go down to the next level, down, go 14. Boom, it kind of fit in there. We can move it around, by the way. So we can move that down a little bit. Okay, boom, it fits. Make it fit. And in here, we're going to pretty much repeat the same thing because that's all the information we have. 425 space MENG3125 problem set 7 shaft design. The whole idea here is communication. We want to make sure that people are clear as to what it is they're looking at. And I don't know, where did my the little controller for the, there he is right there. Let's see, what can we make this, 18? No, it doesn't fit. 16? Maybe. Yeah, that fits. That gets right in there. And I think problem set needs to go down the next line. You don't think these things matter? They matter. They matter. We need to know what school we're going to, right? There you go. You got to hover around there to get that thing in the right way. I'm going to go all caps. What's the name of this place? Yale University. All right. And then we got to know who you are. So you got to go drawn. Who drew this? And I just like me some Dr. Deal naming. It's just all kinds of alliterative and things. It's the whole reason we did this. And what's today's date? It's 10/10/25. You don't need to have any checked. Nobody did any of that stuff. All right. Something down here, we need to fix this. We are not a 1 to 8 scale. So let's go 1 to 4. So we're truthful. And a lot of this stuff is BS. We're not in inches. Let's make sure we're in millimeters. Material. No, not you. I want you here. Where are you? You gotta hover. There you go. There was already a thing there. Material is AISI. What were we? 10. I forgot. What did we say we were going to be in the beginning? We were 1018 cold drawn. And we couldn't actually, if we wanted to finish, we could do that down there. 1018 cold drawn steel. And by the way, some people like all upper caps everywhere. Let's just do this for, because we would like to have a cold drawn. or machined. Either way you want to say it, it was machined. We don't really need this thing. I actually get rid of them a lot. There's this. Is it proprietary? No, then don't include it. Yeah. What about this thing right here? I don't know. I don't even know what next assembly used on. This is for a larger drawing, so it's kind of a generic thing. By the way, you got to go to sketches and trim. There's like an auto trim thing going on here. I think you need that. The other ones aren't continuous, so you could just delete them. Anyway, I like to have a fully filled out. Why are you like the way you are? I don't know. Let's close them down. I like to have filled out as much as you can and everything to be accurate as part of this. If you want the weight, we could actually get the weight. I don't think will it let me get into the other right in here? You could go into evaluate. I think first you need to put in what the material is. So we got to right click onto him and go plain carbon steel. Even change the color a little bit. You can change the mass properties right here. You want to look at the density. This is still not the correct density. You might need to change your settings right there. We would rather have kilograms than the grams, and I'd rather everything be in meters, and cubic meters would help me. Don't need cubic millimeters. Can't find my cubic meters now. Where'd you go? There's cubic meters. All right. And let's see. Let's go recalculate. All right. So by the way, that density, 7,800 kilograms per cubic meter, I happen to know is really close to what steel is. 7,700 is often used, but this is correct. So 79 kilograms is what we're going to put onto the weight, which always bugs me because what are we doing here? Where is? There you go. So no, I don't want to click on that. Do I want to click on, is there a guy next to him or is it just this guy? I think it's just this guy. There you go. Nice and complete. All the information on there. All right, so get out of here. Is he going to let me out? Nice. All right, we're ready to go. Let's save it. Save all. And let's print. So I'm going to go print and a PDF, but here's the thing you need to know. We're going to change this page size to paper size tabloid. Boom. And now it's to a PDF. Let's preview it to make sure it fits. Everything fits. Ooh, nice and fitty. And now we're going to hit print. Hit OK. And I'm going to save it to my right here for the video. So this is the one. Boom. And now we have a nice drawing. Check it out. Ooh. It does seem a little busy, and I am crossing some lines like I said not to. Unfortunately, you can't do it. And we have these reference things. Those are the most important. Make sure that we landed exactly in the machine. And I think you could build this from this, which is the whole point. And what was the video going on here? 1 hour. Sorry about that. Hope somebody gets something out of this. Yay. You could do it. Hopefully you put it on fast, like double time speed. So now it's a half hour.